Hey, Matt Mathersum here with Matt Madness. Thank you so much for joining us and being a part of the program today. We do truly appreciate it. Before we get started, I need to give a shout out to my friends, family, and colleagues over at Paws Saving Paws, wonderful organization rescuing shelter dogs out of San Antonio, Texas. If you are in a position to help, please reach out to these guys and help. They need all the help they can get. Paws Saving Paws. You can even go over to my TikTok channel at That's My Dog. Listen to the podcast. If you're interested in being on the podcast as well, reach out to me there as well. All right, today we will be dealing with the squeeze theorem. For those of you who don't have fun with just one function or two functions, but you need three functions for your life to be complete, well, this show is for you. Squeeze theorem. Let's look at my beautiful drawing first. This is going into the Louvre in Paris, France, by the way, FYI information. All right, well, the squeeze theorem, real simple, before I have to read you the formal statement, is when we have a lower function, f here, and we've got an upper function of h. Well, when we have this middle function here of g, if this limit f and this limit h are the same, then g has no choice but to achieve the same limit. Now, that's my version. I have to read you the formal statement because this math can collapse at the end if we don't have a real good grasp on it. So here goes. It says that if f of x is less than or equal to g of x, which is less than or equal to h of x, when x is near a, except possibly at a, and the limit as x approaches a of f of x equals the limit as x approaches a h of x, those limits are equal, then the limit as x approaches a of g of x equals those two limits as well. Think about this from a geometric standpoint. If two angles are complementary to a third angle, then those two initial angles are congruent to each other, right? That's kind of how I look at this as well. All right, let's also use another visual aid here. This will help because this is kind of an abstract concept. So we've got a riverbank on one side, we have a riverbank on the other side. All right, and in between it, we have that river, and we have a leaf flowing down the river, minding its own business, enjoying a nice sunny day. Well, if this limit here of f is the same limit as h, this g is going to follow those limits as well. Let's make this sucker flip up on its edge now, okay? We've got this guy here, that's the riverbank. This middle function is the river with the leaf flowing through it, and this top function here is another river bank, okay? These guys are squeezing this middle function together is the gist of this. What's the hardest part out of all of this mess? Well, it's setting up those inequalities really is where you're getting started, but this is Calc 1, so you're only going to be dealing for the most part with sine theta or cosine theta, and those are between what? 1 and -1 inclusively, right? So it's not going to be anything really too difficult. All right, let me step over here and let's get to the topic of today, which is going to be find the limit of this function. Well, how do I even know that the squeeze theorem is appropriate to use in this situation? Well, let's see. I've got x approaching 0, so that means my x to the fourth is approaching 0, which is going to be 0. I've got my constant here over something that's getting smaller and smaller and smaller, which means that this x is going to be going to either positive or negative infinity, doesn't it? Well, I've got this cosine attached to this quantity as well, and we know cosine is just this function here, isn't it? So since this wave is attached to this something going to nothing or infinity, the concept, we can't take the limit here, right? We've got a 0 times something that we can't define. However, it is bounded with the cosine. Remember, we said sine or cosine theta is bounded between 1 and -1 inclusively. So we can use the squeeze theorem. Actually, this is a perfect example, which is why I chose this to use the squeeze theorem. Okay, well, let me do away with the wave here. Clean this up a little bit, and we'll get to the task at hand. All right. Well, we said to begin, we have to bound this. The cosine is going to be between what was that? -1 and, or let's say 1 and -1, -1 and +1. If we can get that right today, that would be good. Let me see if I can get this straight here. All right, there we go. -1. All right. Well, what's our cosine theta out of this? Well, that's going to be our 2x, right? So let's go ahead and rewrite this inequality here. I've got cosine, and I'm going to substitute for my theta the 2x. I should say the 2 over x, not 2x. My mistake. Easy to make. Okay. Well, the gist of it now is I'm going to make this, the cosine 2x, look like the function that we're taking the limit of. I need this x4 cosine 2 over x. I've got the cosine 2 over x for sure, don't I? but I need this x to the fourth. How can I go about doing that? Well, a little algebra ought to take care of this. And let's just go ahead and distribute the x to the fourth through all of this mess, right? Now, I know what you're thinking, Matt, we've got a negative here. Are we going to have to flip these inequalities? You're very astute, but fortunately we do not, because the x to the fourth is a positive in this case. Ergo, we don't have to switch any of these inequalities around. Go us. And yes, I did choose this by design. It's not a fluke. Okay, let's go ahead and take the x to the fourth and multiply that by our -1, giving us a negative x to the fourth. All right. Now I'm going to go ahead and multiply the x to the fourth to the cosine 2 over x here. And that's going to give us, well, it's going to give us this. Is this starting to look like something we might recognize? Yeah. So now I've got the cosine times, I've got the x to the fourth times cosine 2 over x, and that's going to be less than or equal to x to the fourth times a positive 1. So now I've got x to the fourth. Does this look like the function that we're trying to find the limit of up here? It most definitely does. Even with my writing being a little sloppy, we definitely got the handle on that. What else do we have? Well, we've got this here, right? And that's our f of x, right? That's our lower function we talked about. The x to the fourth cosine 2 over x is our g of x function. That's our leaf in the river minding its own business. And then the upper function we said is the x to the fourth. That's the top of the riverbank. Right. Well, what do we do now? We're trying to find the limits. What are we finding the limits of? Well, the problem here is as x approaches 0, and we only have to take the limits of the bottom, remember? The bottom and the top function. And if those two guys are equal, then what? Yes, we will rejoice because we know g of x is the same limits. I'm not going to keep you in suspense any longer. Let's do it right now. So I'm going to take the limit of the bottom function as x approaches 0 of negative x to the fourth. Well, direct substitution will take care of this situation. If I plug in 0 for our x value, that's going to give us a whopping 0. Doesn't get any more magical than that, does it? Well, the top function, x to the fourth, let's do the same limit and see if this shakes out properly. We've got x approaching 0 here as well. I've got my x to the fourth. Am I going to use direct substitution again? Yep, I sure am. And that's going to give me a, if I plug in 0 here being raised to the fourth, yeah, it gives us another 0. Well, it looks like I've got a limit over here of 0, and I've got another limit over here of 0. That's one of the things you have to look out for. If these two are not equal, you probably have messed up somewhere in your inequality, all right? Just something to look out for. So now we have to make another formal and final statement here, especially if you're in school, you'll probably be required to do this. So this implies that the limit of x raised to the fourth cosine 2 over x as x approaches 0 also equals 0 by the squeeze theorem. And I'm telling you this because you will probably have to do this in school to get full credit. This implies the limit as x raised to the fourth cosine 2 over x as x approaches 0 equals 0 by the squeeze theorem. Well, that's all the time we have for here on Math Madness. I'm your host, Matt Mathersum. I hope this has been helpful. I'm going to see you guys really soon.